Alright, welcome. It's a new unit, a new set of notes. So this notes we're all talking about motion. It's unit 2. And it's part 1 of our notes. And unit 2, part 1 of the notes is going to be about two things: speed and position. So let's start with position. Position is the location of an object at one instant. So it's where you are right at that moment. So here is a person, and we'll mark them at a position in space. So that dot right there is their position. That's where they are. So different than position, we usually also give ourselves what's called an origin. And think of this as like that 0 point. So position's always marked relative to the origin. So it's kind of like it's just the 0 point where everything is 0. It's usually the start. So we'll mark our origin for our person right here, 0, right where they're standing. So let's say our person decides to go for a walk across the page, and they walk to another point right here, and they're now standing. So they moved. They moved to a second position. They're in a different spot. So if we change our position, that's something that is called displacement. And that's the net change in position. So we like to mark our position as to where we are, usually, especially when we're looking at one-dimensional motion. We'll mark it with an X, right? So where you are. And our change in position, we write delta X. So that's a delta. And delta means change in and then our X means position. So when we say displacement, we write delta X, change in position. So we can have a coordinate system with an X and a Y and even a Z coming out. And we can have a point in that coordinate system with an X, Y, and a Z. And we can move to a new X, Y, and Z. And we can have a change in X, a change in Y, and a change in Z. And all of these would be our displacement. So displacement is a net value. That is, it doesn't matter how you get there. We just want the shortest path. So if I start here at this dot, and then I go up to this dot, and then I go over to this dot, my displacement is the straight line path between the points. So displacement is the shortest path between the 2 points. Doesn't matter how I get there. I can go up and over, or I could go at a big path all the way around. Doesn't matter, my displacement is still the same. Displacement is also a vector quantity. So what does that mean, to be a vector? So a vector is a special kind of measurement and something that has magnitude and direction. And magnitude is just a fancy way of saying size. So how do I show magnitude and direction? Well, if I start at 0 and I run to a point, and we'll say to 5 meters away, then x1 was 0, x2 was 5 meters, and my change in x is a positive 5 meters. So that positive tells me the direction. I could also say 5 meters to the right, or 5 meters east, saying that up is north. All of those are acceptable ways to say that how we moved about as our vector. When we look at, so when we look at vectors, we always add that direction. Now, not all things are vectors. For example, there's another way of measuring how far, and that's distance. Distance depends on how you get there. So it's how far you travel total. Okay, that's different than displacement, which is like how far you are from the start. So this, the path matters. And this is what's called a scalar, which means there's no direction. Distance is how far you went. It doesn't take into account which way you went. So when we start looking at distance and displacement, we start talking about how fast. That involves something called rates. A rate is a quantity divided by time, basically. So you could even say it's how much over how long. So we can write like this: how much over how long. So it could be, you know, I ate 3 candy bars in 15 minutes. That equals 1 candy bar per minute, or 5 minutes. Excuse me. So it takes me about 5 minutes to eat a candy bar. That's the rate at which I ate the candy bar, so we can simplify it. And speed, we've said, is the distance, the rate of distance traveled, which means that it becomes speed equals distance divided by time. So that's different. That's distance is not the same as displacement, right? That's different. Distance is how far you went. So when we talk about average speed, that's what we've been looking at a lot in class. But what we really want to talk about with physics is not speed, but we want to talk about something called velocity. And velocity is related to speed, and we mark it with a V in our equations and whatnot. And velocity is the rate of change in position. So if we break that up, it's a rate and it involves change in position. So we know already that velocity is going to be a rate, which means it's something over the time. And if it's change in position, we know that's change in position, which is displacement divided by time. And we can even write our velocity as this, x2 minus x1, because that's the change in x over the change in time, t2 minus t1. And a lot of times we start at 0. So when we start at 0, x1 and t1 are going to be 0. So that's the velocity. But position, we said, change in position, right? This is displacement. And displacement was a vector, which means velocity is a vector. That's important because that means velocity always includes how fast and direction. So earlier we said our change in position for that person was 5 meters to the right. We said a positive 5 meters. We said delta x equaled positive 5 meters. If we say that took 10 seconds, then our velocity over that trip, our average velocity would be delta x over delta t, which would be 5 meters over 10 seconds. 5 divided by 10 is 1/2. And we have meters per second, because we have meters on top, seconds on the bottom, and we keep our units. So velocity is also measured in meters per second. That's the unit that we like to see for velocity. All right, well, I think that's about enough for now. We'll stop there. That's essentially speed and velocity and position. We will practice on this week. Next time we're going to talk about graphing and how the graphs should look and what the graphs mean. And then we'll do a little bit more practice with some of these velocity problems in the future. And we'll also practice in class. So thank you for watching, and you have a day.